Myself, Rajendra Karale. My qualification is MSc Chemistry B.Ed and experience is of 28 years. Now, today we are going to discuss about second example, that is formation of ammonia molecule. Now, formation of ammonia molecule can be explained on the basis of sp3 hybridization. Now, what are the steps involved in this case? First step is the molecular formula of ammonia is NH3. Meaning is that it contains one nitrogen and three hydrogen atoms, and here nitrogen is the central atom. Now this is the first step. Now write down second step. Electronic configuration of nitrogen in the ground state is here write down N 1s2 2s2 2p3, that means here apply the Hund's rule, that is 2px1 2py1 and 2pz1. Now third, here nitrogen atom contain three unpaired electrons in the valence shell, and here nitrogen is trivalent and is bonded to three hydrogen atoms. That means here number of unpaired electron is equal to valency. That means number of unpaired electrons are 3 and nitrogen is also trivalent. That means here formation of excited state is not necessary. That means here electronic configuration of nitrogen in the ground state as it is. That means here N7, 1s2, 2s2, 2p3, that is 2px1, 2py1 and 2p z1 here. Now here write down nitrogen atom undergoes sp3 hybridization. That means here in which one 2s and 3 2p atomic orbitals mix up thoroughly to form here 4 sp3 hybrid orbitals with equivalent energy. Now here 4 sp3 hybrid orbitals are formed. 3 of them contain 1 unpaired electron and 1 of them contain a lone pair of electrons. That means here write down hybridized state of nitrogen atom 1s2 remain as it is, and here you can consider these 4 atomic orbitals are mixed together and you will get this 4 sp3 hybrid orbitals. Now these 4 sp3 hybrid orbitals of nitrogen atom That means three of them contain unpaired electron and one of them contain a lone pair of electrons. Are directed towards the four corners of regular tetrahedron. In order to have minimum force of repulsion and acquire maximum stability, now one sp3 hybrid orbital contain a lone pair of electrons expand over a greater region in space cause greater force of repulsion on the remaining three sp3 hybrid orbitals and bond angle is reduce. Hence, geometry is hence the arrangement is distorted tetrahedral or pyramidal with bond angle 107 degree 28 minutes. That means here draw this diagram. This contains lone pair of electron. This is one sp3, this is another sp3, this is third sp3, and this is fourth sp3. This bond angle is of 107 degree 28 minutes, and here write down figure 4 sp3 hybrid orbitals. Now here write down the electronic configuration of hydrogen atoms in the ground state is that is H1s1. That means it contains only one electron in the valence state. Now here write down next point. In the formation of ammonia molecule, three sp3 hybrid orbitals of nitrogen atom containing 1 unpaired electrons overlap coaxially with half-filled 1s atomic orbital of 3 hydrogen atoms. Here to form three strong sigma bond between nitrogen and hydrogen atoms by sp3s overlap. That means here this is one sp3 containing lone pair of electron. Here draw the back lobes like this. Now keep in mind the most important point is that hybrid orbital also consists of two lobes. One lobe is large and another lobe is small. Now this is the one hybrid orbital and it has two lobes. This lobe is large and this lobe is small. Now here these three atomic orbital, that is those containing unpaired electron, overlap coaxially with half-filled 1s atomic orbital of 3 hydrogen atom. S atomic orbital is spherically symmetrical. This region is called as overlapping region and type of overlap is sp3s, and here bond form is nothing but the sigma bond. Here also draw. Again this region is called as overlapping region. Here type of overlap sp3s and bond sigma bond, and here also overlapping takes place. This region is type of overlap is sp3s and bond form here sigma bond. That means here write down lone pair and here write down the bond angle, that is 107 degree 28 minutes, and here write down figure overlapping of three sp3 hybrid orbitals of nitrogen atom with half-filled one s atomic orbital of 3 hydrogen atoms. Now then next point, Here ammonia molecule adopt tetrahedral geometry. This is because here hybridization of nitrogen atom is sp3, or in this case the nitrogen atom is surrounded by 4 electron pair, that means 3 bond pair and 1 lone pair. But here one of the position is occupied by a lone pair. Hence, geometry of ammonia molecule is distorted tetrahedral or pyramidal with bond angle 107 degree 28 minutes, in which nitrogen atom is present at the center, three hydrogen atoms are directed towards three corners and one lone pair of electron towards one corner of distorted tetrahedron. That means here this is lone pair, here write down H, here write down N, H, H. This bond angle is of 107 degree 28 minutes, and here write down figure formation of NH3 molecule. Now this is regarding about the formation of ammonia molecule on the basis of sp3 hybridization. Now here we will discuss about the important terms involved in this example under the heading of keep in mind. That means here write down keep in mind serial number, molecule, then hybridization geometry, bond angle, number and types of bond, and here write down overlap. Now here write down second ammonia, that is NH3 hybridization is sp3. Here write down ammonia, geometry is distorted tetrahedral or pyramidal. Here bond angle 107 degree 28 minutes. Number and types of bond. Here write down 3 NH sigma bonds and 1 lone pair of electrons, and here write down overlap sp3s. Now here write down techniques. That is, given molecule is ammonia whose formula is NH3. Here nitrogen atom is bonded to the 3 hydrogen atom. That means here number of bond pairs which is also called as sigma bonds equal to 3. Now let us calculate here number of lone pairs. Now the atomic number of nitrogen is 7. Its electronic configuration is 2, 5. In the valence shell there are 5 electrons. Therefore write down here 5 minus hydrogen atom is monovalent. That means each hydrogen atom shared 1 electron. So 3 hydrogen atoms share 3 electrons. That means 1 into 3. Now here you will get the number of electrons remain on the nitrogen atom. Convert this number of electrons remain on the nitrogen atom in the form of lone pair. For this purpose, divide this term by 2. Because lone pair means one lone pair consists of 2 electrons. That means here 5 minus 3 equal to 2. 2 by 2 means 1. This 3 plus 1 equal to means 4. That means here you will get number of electron pairs. Now here number of electron pairs are 4. So the expected geometry is tetrahedral, and bond angle, the expected bond angle is 109 degree 28 minutes or 109.5 degree. Now this case is applicable only when if the number of bond pairs equal to 4 and number of lone pair equal to 0. But here number of bond pairs are 3 and number of lone pair is 1. Therefore here the geometry is disturbed and actual geometry is distorted tetrahedral or pyramidal with bond angle 107 degree 28 minutes. Here total number of electron pairs are 4, meaning is that 4 hybrid orbitals are required, and tell me which hybridization gives 4 hybrid orbital? sp3. That means the nitrogen atom which is present in the ammonia undergoes sp3 hybridization. Now in the simple sense here, this nitrogen atom is surrounded by 4 electron pair. Hence the geometry of ammonia molecule is tetrahedral with bond angle 109 degree 28 minutes or 109.5 degree. But here one of the position is occupied by lone pair of electron. So the geometry of ammonia molecule is distorted tetrahedral or pyramidal with bond angle 107 degree 28 minutes. Now you can use this technique in the board exam as well as entrance exam like MST-CET, NEET and JEE in order to find out the answer quickly, that means within short time with 100% accuracy. This is regarding about formation of ammonia molecule on the basis of sp3 hybridization, and the remaining part of this unit will be discussed in the next lecture.